So hopefully everything's good with them. We were messing with creating views on Monday and covering most of that chapter. So one of the things, we created a view here. We joined some tables together. And again, joining of tables together, I think it's talked more about in, I believe, chapter 11. But one of the big things in creating views is you join multiple tables together and query information out of multiple tables. We were able to join a table to itself because of the manager ID related back to the employee ID. And we were able to use that view, hide that complexity of the select statement so that we could easily query the table and check who managed who. We could easily put a where statement in here and look at the manager column and look at a particular manager, maybe Edwards, and get all of his employees that he manages in a single list. So however that you'd want to query the database or view that, our view made that easy. I wanted to expand upon views. I wanted to mess with, I guess, our chicken farm that we created. I'm actually going to drop all the views that I created from Monday out of the Chinook database. I had a report P. I'm going to drop that one. And you could keep your views in your system if you wanted to, just to look at back later if you wanted to keep that code. I'm just going to clean it up out of mine. You don't have to delete. You can open up a new SQL on your chicken farm. Let me look at our diagram and our SQL code. Okay, so we're going to play with the eggs table and create a view off of the eggs table for 2021, specifically 2021. So a function of view, we're going to make an updatable view. I can see all of the columns, but we're going to use a check option with it just to see that work. So let's create a new view. We'll name it eggs 21. I'm going to select all the columns. I'm not going to specify any columns or rename the columns. Select star from eggs. Where collection dates between January 1st, 2021 and December 31st, 2021. With check option. This is the last part of the view that's wanted to go over out of chapter 5. And the only thing that I've really done differently with this view is I did add in a where statement where I'm limiting what the view number of rows is going to be displayed onto the screen. It's going to only show eggs collected this year. Whereas if I did a select star from eggs by itself, it would show eggs collected from every single year that we run this farm. I've added the key part right here is with check option. So that is the code that will make this view impossible to put in a date outside of the 2021 range or modify existing rows outside of that range. Let's go and create the view. It should execute successfully. With the code visible on the screen, I wanted to show how that this code actually operates. So I'm going to insert data into the eggs 21 view. I don't have any aggregate columns in this view, so it is an updatable view, meaning I can put data into it. I can insert into eggs 21. And if I put stuff into all of the columns, I don't necessarily, and as long as I put the values in correctly. So we've got a generator I can specify default, but the collection date's gonna run the default value. The number collected is an integer. We collected 12 eggs today. Daylight hours, 603 minutes. And the high temp today is 35 degrees. So I executed that. And it said successful.
All right, how did it execute on the first?
Did-
That part.
Oh, you will. Let's see. You didn't highlight the C. Relation eggs does not exist, so you're connected to Chinook. Hit the drop down up there. Select off of Chinook to up there top center. Yeah, Clicker Chicken Farm. Now just hit F5 and it should create everything. Should run all statements with no error. Okay, so I'm going to copy this insert statement. Just so I can put something else in. I'm going to say I forgot to put in yesterday's values, so I'm going to put in the date. What was it? See, 02 dash. Yesterday was the 9th, 2021. And yesterday, we'll say we collected 15 eggs, 602 minutes of daylight, and it was 42 degrees yesterday, or the high. I'm going to highlight and execute just that statement. So if I view what's in the table now, just to make sure, I should end up with a couple of rows. Into the table. So nothing's different than if I just inserted values straight into eggs, or if I inserted values straight into eggs 21. Let's say that we missed something from 2020, and we're going to enter a value from 2020. I'm going to make a third insert here. And we forgot the eggs that we collected on New Year's Eve of 2020. We collected 7 eggs, and there was 583 minutes of daylight. And it was 67 degrees that day. Arkansas is warm. I'm going to go ahead and try to insert and execute that. And what happened?
The value was outside the view and the where statement. So.
Yes, so we got an error as expected. That's what we're wanting to see. Because when we created the view, notice the where statement has us limiting between 21 as the year. And the check option enforced that the view cannot accept values outside of the where statement. So yes, our where statement only allows values from January 1st to December 31st to 21. When we try to enter a value that was from 2020, we get the error. The check option blocked us. If we didn't put the check option with creating the view, it would have accepted the value, but when we queried eggs 21, it would not have shown that value. So the check option just makes sure that you can't enter values that you can't see using that view. You don't have your eggs created over here. Where's your original SQL code? Yeah, so from there, click, thought you ran all of that before. Let me refresh and see. You created it in Postgres. You drop all of those out of the Postgres, and okay, they're dropped. Okay, so now I'm not sure why some of these. I think those are old errors. What is yours doing? Okay, so that executed correctly. Expenses are in there. The collection date, number collected, daylight, high temp. I'm not sure why yours is throwing an error. Shouldn't have an issue since they're down there. Well, I guess trying to execute stuff from over here. It's coming up to here and saying this doesn't exist. I don't know. Date's not working. So I guess trying to execute every single one of them. Trying to execute this. I guess we're gonna have to close that out. I think I have to close this one out. Okay, the view exists. We got eggs. I don't know why it's underlined. So eggs already exist. Eggs doesn't exist. Um, sure, we'll close that out and reopen DD Studio Forge. Okay, reopen DD Studio Forge. I can't see her taskbar. Okay, so we reconnected. Eggs are there. There's existing connection. Okay, we're reconnected. Okay, I think it seems to be working now. It did insert that. That statement's good. The program was glitching. I don't know why it was glitching, but it was glitching. It's no longer glitching out. Just had to close and open it again. It's like trying to execute everything in every single tab and just being weird. Okay. So you can't insert a value that is outside the range. If I take off the 21 and insert directly into the base table for December 31st, 2020, and I go ahead and execute that, it does work. If I run the select statement from the view, well, the view doesn't show me that third one. If I delete the 21, select star from eggs to view everything in the base table, it does show me the 21. I just wanted to show that portion. They did talk about it here in the book, about what is the with check option, how does it work. I hope that shows you how that works fairly clearly. So anytime that you create a view and you're limiting the number of rows, you can add the with check option. And see everything. Let's look at how that would work if we dropped the view and deleted the with check option. If I get rid of the with check option and I do a drop view eggs 21 semicolon, if I recreate this, and if my last view and select statement, if I go and add the 21s back onto here, I put in another value of December 30th of 2020. We collected 9 eggs that day. That was 281 minutes of daylight. We had a 48 degree high temperature. So if I change and throw in a 4th row into the table, will it work? So I did not get an error this time. In my view, I don't see 12/30/2020 because the view is limiting my output to only 2021. If I view just the base table, I can see all 4 of them. So the check option allows you to not hide stuff from yourself. So if your application was utilizing the view for entering in data, users could accidentally, type in data that's outside of a range and put data into the database and not actually tell that it's in there correctly. No way for them, if you're just using the view, they would have to go back and view the base table itself. And of course, users are not writing SQL code, they're using the application. So based on how your application's coded, if it's only using the views and not the base tables, that would check option can become fairly important. You can block people from putting in bogus data or data that they can't not see. Okay, so I think views are pretty easy, at least creating them. The hard part is the part after the as, because that section right there can become quite enormous and complex. But as far as create view and listing out columns optionally, dropping views and stuff, they're pretty easy to use. And hopefully you agree that they're fairly easy to use and create. And they're optional. You don't have to use them. And I say lots of databases probably do implement views, especially when you have to relate 3 or 4 tables together. Okay. Any questions on views? I did see a check constraint over here in my code that I'd put into my laptop, but for some reason my check constraints did not flow across. This would have been chapter 4 with the check constraints, but I have some check constraints on the create table eggs. I don't think anybody else added any extra check constraints on the eggs table. I thought I had the code in here, maybe not. So the high temperature, I don't know why it's missing, but I'll go ahead and put it back in to my eggs table. The high temp, I created a constraint to basically I created this constraint called check high temp. And there's a bunch of different constraint types up there, like unique, primary key, foreign key stuff, but I use the check constraint. And the check constraint had to do, I'm pretty sure I have to use parentheses here. I had to check that the high temp was between 0 and 120. So did I not have that? Anywhere? I guess I didn't. When I was developing this database, I was thinking this would be for Arkansas area. And that we're picking for, a hobby. We're not picking to make this here sellable to anybody, and it's just for this class, but that way we can narrow our experiences. Some of us weren't lucky enough to live in Alaska or other states. We've been here our whole lives, so just thinking about where we are here in the weather and how you might add constraints into this database. And of course, a temp between 0 and 120. If you're making this for a worldwide application or something, you would probably maybe need to expand that. High temperatures, at least the 0 there, you might have to go into the negatives. Minnesota is going to have negative high temps, but for Arkansas, I don't think we've ever had anything as a high temp below 0. We've had some record lows of like 6 below, 8 below and stuff, but I've never heard of a high temp below 0 in Arkansas before. So throw that in, check constraint. That would prevent us from putting in bogus values into the high temperature column. So we're getting close to break. I want you to create a check constraint for the daylight. I want you to figure out what is the shortest day in minutes for Little Rock, and what's the longest day in minutes from Little Rock. Set the daylight temp. See if you can go figure that out and create that constraint. Once you figure that out, you can go ahead and take a break. You'll probably have to Google it, I'm sure, to figure out the numbers. I need to resume recording here after break. So I didn't show I don't think I showed the constraints that we added into the eggs table, and we didn't actually implement them yet. We're going to fix that with an alter statements on Friday in class. So jumping into chapter 6, let's preview the PowerPoint here. Need to learn how to swallow. So no, it's not COVID cough. Authorization identifiers. You have a SQL implementation talks about vendors implementing a user identifier, and there's no real specification on how the user identifier is implemented in SQL. They might implement it using the operating system user accounts. They might implement it using an internal database user account. But you have a user identifier. So here we got database user, computer user, domain user account. Depends on how the vendor is going to implement their system. They may require Active Directory for it to have a user to access the database, or it's all vendor specific on that part. Postgres actually doesn't really have a user identifier. They just have roles. They do have a role that acts similar. You can create a role to make it act kind of like a user identifier, but they're all just really roles. I'll show you the SQL, Postgres SQL implementation in a little bit. The role identifier, it's basically if you've done Active Directory or dealt with computers and permissions, you probably heard of a group before. So the role identifier is kind of similar to a group that you might see in other operating systems, Linux groups, Windows groups and stuff that you add user accounts to. It's best to design your database with roles instead of user identifiers. So you pre-create the database, you create these roles, and you give them permission to different tables or columns. I believe Oracle even lets you set permissions on individual cells in a database. That's not part of the SQL standard. The SQL standard doesn't have anything about setting individual rows or cell permissions, but some vendors add a lot more robustness and capability to their permissions. As far as roles go, you define them on a table. You define them to give access to the particular database. You can even define down to the attributes or column if you want to. So why is it better to use them instead of users? Well, you're probably developing your database to be shipped out to customers, and they're probably going to have their own user accounts that they're going to create for people who's going to use it. And as you're creating and playing with it in-house, you're just using some sample user accounts, probably not anything that an end user is wanting to use. So instead of using those and utilizing any type of user accounts that you created, you set permissions on the role. That way, when you ship a product, the role actually goes with the database. User identities don't when you ship your database. So that's one cool thing. Roles don't have to have anybody, a member of them, for them to exist. User accounts typically have to exist in the operating system for it to work. So really great. Just use roles, set permissions, and then the end user will create user accounts in their operating system and define them a particular role to give them whatever rights into the application database system that you've got. So that was your second or third bullet here. Roles can exist and be assigned permissions to a database object without the need of creating user accounts first. And that's why you should use the roles as permissions everywhere versus user identifiers. There's a special role for public. Don't use it. It's the same thing as everybody. And most coding people have that as a policy not to use the public. So pretty much anonymous is just about what public means. If you can get a connection to the database, you got access to whatever public has rights to. So try to avoid assigning public rights to anything. But it's a built-in role that you should avoid using. SQL sessions always starts with the user identifier. And then when you execute statements, the statement can be executed typically as a role name or as a user identifier. And then it reverts back to the user identifier. That's kind of weird to think about, but you authenticate into the system with the user identifier, and then you're assigned a role permission, but that role permission is the computer is not actually tracking your role until you actually say, I want to view this table. When you actually execute that code, it looks at that table and sees what role has rights to that table. And if you're a member of that role, the statement executes as that role's permission, not as the user identifier's permission. Normally how the thing works. So the last one down here, only one session identifier is presented when you execute a statement. The other identifier is set to null. That's kind of odd to think about. Looking on page 130 in the book shows your SQL session in the graphic. And as you log into the database, you're assigned the user identifier and your role is null at that point in time. But when you execute a SQL statement, then it typically executes as a role instead of the user identifier. That's the way it's designed to operate. Kind of weird. The main thing to really be concerned with in this section, because vendors implement the use of user identifiers and roles differently, is privileges that you can assign. Privileges that you can assign to objects in the database, like a table, base table, or row, or constraints or different things. These are the different keywords that you can give rights to a role. Select would give a role the ability to view stuff. Insert, guess what a role would be able to do to a table? Put data into it. Update, they would be able to change existing data onto a table. Delete, they could remove data from the table. References, they could create foreign key, primary key links. Triggers, they can create triggers. They can execute procedures. What was usage? Usage, why did I forget what usage was? It's here on page 134 in the book. That's dealing with assigning a domain to a column. So what domain is a column usable in? And then we have under. And it's basically saying a user is able to define or grant permissions to subordinate tables, it looks like. So the usage and unders not very often utilized. The main ones that we will be playing with this week are the top 4. select, insert, update, and delete are the main ones. Possibly references in there if you're wanting to design the table, but if you're designing the table, you probably want to be in as a super user and have all privileges to everything. When you're actually going to narrow privileges down, you're creating roles for the end user, for the company that's going to use your database, and you're setting up where that maybe certain users can only view stuff out of the database. You might have some users that can insert and update data, and you may have a supervisory user account that's going to do select, insert, update, and delete. As far as the developer stuff, you might want to restrict the bottom 5 privileges to just your in-house developers. Make the company have to call you and pay you thousands of dollars development fees to create any new triggers or stuff like that that might need to be designed. So applying privileges to the system, you have grant and revoke are your 2 statements for applying privileges. And they are the keywords grant, revoke, followed by the list of permissions. In the top rows, granting select, insert, update, and delete. So the 4 common ones for a customer to use on a particular table. So keyword on, the table name, and a keyword to, followed by the role name that you created. You can remove permissions from a table by simply changing out the word grant with revoke and the word to from. That's the only difference between the 2 statements here is the word grant. If you're removing it, has to be revoke, and you're revoking it from somebody. You're not revoking it to somebody. They try to use actual grammar to make sense here. So you're revoking from a group. Not a very complicated apply and revoke here. Roles, well, create role, give it a name. Delete a role, drop role, type the name of an existing role. You can also grant all privileges to a particular role. Basically give them almost like administrative rights. Grant all privileges on a table to a particular role name. Or you could do as before, grant certain privileges, comma, separated out on a table to whatever role name that you created. How do you add a role to a user? Somebody's got a Windows login and you want to have that Active Directory or Windows login given a specific role to use the database. Well, you grant the role name to the user ID. And the same thing with revoke. You can revoke a role name from user ID. So here we get into, I said I'd show you Postgres documentation. So Postgres doesn't actually have a difference between a user identifier and a role identifier. So Postgres, you can, on a Linux machine, switch over to the Postgres user and issue a create user command. The Postgres is installed onto Linux machine and with the following like interactive and password prompt, and it'll just go through a script and ask you how to create a user account inside the running Postgres server. If you're already connected and have a SQL prompt like we are using with our DV Studio Forge. We're actually writing SQL code into it and not from a command prompt. You can use a create user command. You could also use a create role command. Either way works. Follow with John Doe with password, pass 1, 2, 3, 4. If you use create role, bring up the documentation. So I'll close it. Okay, so Postgres. I say Postgres doesn't really have a difference between role and user. When you create role and type in a particular name, what's the difference in that and using create user in a particular name? Not really anything. The create user is actually just linked to this create role command. They're almost identical, except when you type create role, when you type create user, it automatically adds the login option to that role. If you do just create role and a name, it automatically should add the no login option that you can't use a password to authenticate directly as the role. So they've just kind of got a toggle switch. Can you log in as a role, or is it a no login on that role? That's how they differentiate with Postgres, with a kind of a simulation between a user identifier and a role. So the way they logically implemented it, slightly different than somehow like the book said, the user identifier is implemented by the vendor differently. And in Postgres, they're all basically roles. But to give the coder the thought of the difference between the role type, they created two commands. They had a create user command and a create role command. But in reality, it all links back to this one create role. So they call it basically a wrapper. This create user is what they call a wrapper, meaning it doesn't really exist. It just runs the create role command with some predefined defaults. So, but does it really matter, the technical part? Not really. You can just imagine create users, create a user account, and create roles, create a user a role. You can still visualize that logically and not have to concern yourself with the complexity. Let's play with our chicken farm here. Create a new SQL. Let's create a user. And Armor. That's going to be our user. That should probably be a role. Who's our user? Cletus. User's Cletus. He's going to be our chicken farmer. with password. Admin's going to be his password, even though he's not actually going to be an admin. I'm also going to create a role. And then my cap lock's on here. There we go. Great. Create role farmer. I might go and just make sure no login is possible on that. That verifies that it is a true role. And I want to give Cletus rights to the farmer role. I think that's backwards. Grant the role to the user. Yeah. So that would be the code that I would need to do with permissions anyway to create a user account, or really technical with Postgres. We're creating a role that has login ability. We're creating a role called farmer, making it a true what SQL's implementation is. It's a group that doesn't have any login capability. And then we're granting the role ID to the Cletus login identifier. If I hit F5, apparently I was highlighted on something else. We should successfully be able to add in the user and the role and grant those privileges. Okay, let us eat salad. No. Let's give farmer some access to the eggs table. So grant, we'll only grant select on eggs to farmer. Cool. Now how do we make this work? Let's test this out. Let's create a new connection. As I create a new connection, the host is going to be localhost. The user is going to be who? Cletus. The password is the password that we specified. The database is going to be Chicken Farm. And the connection name is we'll just put something like Farmers Access there. I'm going to test the connection to make sure that I can log in. And it says that was successful. Let me test something else out here. Okay. So Chicken Farm connection access. Just gave it a weird name there. I'm going to go ahead and click connect. So in this section down here, I'll right click and open up a new SQL. This connection should be authenticated as Cletus. And if I look at my bar down here at the bottom, the user is down the bottom right, should say Cletus.
So we're trying to do the connection.
Hit test connection. You might try to go to your, go and hit OK there. Go to your go down to your title bar, bring your SQL up. So server window. And you might just try to do like a /Q to shut it down and then relaunch it. Now try to test connection again. So what is yours doing? Another thing I think is close out of EV Studio Forge, go open it back up. Now that it's opened back up, we'll make another connection here. I don't think you actually run this. I think that may have been what it was. You didn't actually create the user account. Because it should have thrown an error that the user is already there. Chicken arm doesn't exist. You didn't run the code to create the user. So it was denying you login rights. Okay, so if I select star from eggs, I can view everything. Cool. What if I try to insert? I'll try to collect stuff tomorrow. Database doesn't care. How many eggs did we collect tomorrow? We collected 3 eggs. It's really cold tomorrow. Daylight's say 604 minutes tomorrow. And the high temperature tomorrow is supposed to be like 30 degrees. Will this run? I don't know. Try it out. Does it work? Or did you get an error? Well, what's your error? So why is permission denied? Do you understand why you can't put stuff in? That's the big question. Can you understand why that's you're blocked from entering data in? So inserts does not work, but select does work. So just review what we did. We created Cletus. We created a role called farmer, and we made sure that Cletus was a member of the farmer's role. We granted select permission to the eggs table for the farmer role. That's all we granted. We did not grant any other permission. Can Cletus access any of the other tables? Can he see anything in breeds? He can't. We didn't give farmer role any access except for viewing the eggs table. We didn't give them access to any other table. Cletus was also created just as a regular user. He was not created as a super user. So he does not have rights to anything. He has no global permission. He's a brand new user account. So why is everything working over in these other windows here? Because we're logged in as Postgres. Postgres is the global administrator account built into the Postgres database system that has full privileges to everything. So if you're logged in as Postgres, you got rights to do anything. Create tables, delete tables, create databases, assign permissions. But as soon as we made a new connection and we authenticated with the Cletus user and his password, here on the SQL number 4, again at the bottom of the screen here, it shows that I'm logged in as Cletus, no longer as the Postgres global administrator account. Then I've only got the rights that are granted to me. Either granted directly to Cletus, which would be in the PowerPoint as something not to do, or granted to one of the roles that Cletus is a member of, which is their recommended. So again, we created a role called farmer. We gave farmer rights to view the eggs table only. Cletus become a part of the farmer role. So that's what Cletus has. So again, with the first couple of pages in the book, we're authenticated as Cletus right now. But when I right click and execute, when the execute happens, it executes as farmer, because farmer is what Cletus is a member of. There can be some other things added into the system, things down here called procedures and functions. You can specify in procedures and functions what role that they would execute as. So when you execute a procedure or function, they would take upon whatever hard-coded role that procedure was defined to run as. So I could be logged in as Cletus and I could run a procedure that was given admin rights and it would run as admin rights. Cool, huh? We'll do some more play on Friday. We'll probably grant some insert rights to the farmer on eggs and then see that we can actually insert. Then we'll revoke and see if we can revoke a privilege and stop them from being able to do stuff. So we'll play with these commands on Friday, give us some more examples of things, and we'll also do the review questions. Go back to chapters 5 and 6. Remember, I think it's chapter one of them, you don't have to answer all the review questions. It says go like 1 through 7 and 11 through whatever. There's a few questions you don't have to answer. We'll review that. We'll play more with the permissions. We'll review for the quiz. I think there's a quiz coming up. I'll have to look and make sure. So fun. And y'all can, if you want, you can play with permissions between now and then.